Hello and welcome back to Vegas October 1 Sounds. Tonight I'm going to address a few comments that were made on some other channels about the sounds of October 1st being fake. And one of the arguments being used was that because we don't hear the trailing muzzle sounds on a volley, that's an indication that the sound is fake. So what I'm going to do is give a brief review of the relationship between the supersonic crack and the muzzle blast, and how many of those muzzle blasts you would expect to hear at the end of a volley, and basically counter their argument with some real measurements. I'll be using this graph extensively, but let's start with the basics. As you'll recall from my very first video, I said that every gunshot produces two sounds. One is the muzzle blast, which is produced by the exploding gases coming out of the rifle barrel, and the other is the sound of the bullet, which produces a supersonic crack along its entire path. And I just refer to them as cracks. One is cracks, which are the higher frequency sounds produced by the supersonic projectile, and the lower frequency or muzzle blast. The bullet, the sound that bullet produces is kind of unique. Along its entire path, it produces a shock wave at every point that it travels. Billions of them. And those shock waves all interact collectively to form a cone, what we call the supersonic cone or wavefront. And when that wavefront hits a recorder or crosses paths with the recorder, then it gets recorded. But it's really only recording a small portion of that wavefront, and the portion of the wavefront that gets recorded is different for every recording location. So you could have two recorders recording the same round of gunshot at different locations, and they would produce slightly different sounds because they're recording slightly different portions of the wavefront. It has a big and their geometry or their locations has a big impact on when those sounds arrive. The muzzle blasts, as depicted here at the lower frequency range of this spectrogram, are easy. You know, they come out of the barrel of the gun, they travel at the speed of sound, you know, and it takes them and if you're 1,000 feet off and the speed of sound is 1,000 feet per second, it takes them about a second to reach the recording. The supersonic cracks, on the other hand, are way different. If a bullet travels really close by the recording, then the portion of the wavefront, of that conic wavefront that gets recorded, is very close. And so the time for that wave to reach you is the time that the bullet travels from the tip of the gun barrel to, in the case where it's very close, to very close, and then a little bit of region where the crack is produced by the bullet and then heard by the recorder, heard by your ears, or heard by the recorders. So if the bullet is really, really close and it's traveling Mach 3, i.e. 3 times the speed of sound, which in this case would be 3,000 feet per second, because the speed of sound we're assuming is 1,000 feet per second, then the crack would arrive at 1/3 of a second. And so the time difference between those would be 1 second minus 1/3 of a second, or 2/3 of a second. And that's what we refer to as the lag, this difference in time of arrival. Now, on the other hand, if the recording were far away, then the muzzle blast and the supersonic crack arrive almost at the same time, and the time difference between them is very, very small. So in this graph we have muzzle blasts on the lower frequency, supersonic cracks on the upper side. There's 8 of them, so we fired 8 rounds, 8 rounds, we produced 16 sounds, 8 muzzle, 8 supersonic cracks. Yeah, I'm going through this a little quick because you can go back and read it in that very first, or listen to it in the very first video I did. And typically, it's easy to measure the lag or the time of arrivals between the supersonic crack and its corresponding muzzle at either the end or the start, because in between it's kind of hard to tell who belongs to who. So in this example, the distance is indicated by the red line. And in this instance, we have 1, 2, 3, 4, almost 5 muzzles produced at the end after the last supersonic crack. And since we know these to be produced just by experience, listening to them at about 1/10 of a second per round, then that's going to be about 5/10 of a second lag. So in this case, this volley, which is volley 5, burst 3, right near the front of the stage, you're going to hear a trailing 5 trailing sounds of muzzle following this thing. Up front you'll hear 1, 2, 3, 4 cracks without any muzzle. Excuse me. And then you'll hear 1, 2, 3, which are a mixture. So here's what's being talked about, the trailing sound of the muzzles. This is for a case where the lag is large. So let's go look and find a situation where the lag is small. Alright, break up my trusty search thing here. And I know that Oasis has a small lag. Or we can go look at the graph. Let's go look at the graph here just to show you how that would be brought up. In this case, we were talking about on the front of the stage, somewhere down in here, either in the red or the yellow. In the case of Oasis, way down here, we see it's in the blue, which are the smaller lags. And light blue is in between, greens and even more in between, yellow's getting close. So yellow and red are the red's 0.5, yellow is probably about 0.3, 0.2, 0.1, and on down in terms of lag. In the case of 0.5 lag, I would expect 5 muzzles to be trailing the end, because after all, for 0.5 seconds of lag and each bullet is 1/10 of a second, we can have 5 lags at the end because they're offset by that lag. Similarly, when we get into the 4 or the 3, let's just go for 3 here, then you'd have 3 muzzles at the end, 2 muzzles at the end for the green, 1 muzzle at the end, and any of these it's just 1 at the end because the supersonic crack always precedes the muzzle for a supersonic projectile. So now the question is, what do we hear? Alright, well, let's go pull up, like I was just about to do, Oasis. And of course I'm going to use Sonic Visualizer. And remember, Oasis now was in, one of the smaller lags. And let's put it to my usual color range and measurements. There we go. So for Oasis, what we have, Oasis records volleys 7 through 10. What we have is a supersonic in this top graph, which is the power graph. We see a supersonic projectile followed by a corresponding muzzle blast. Supersonic projectile crack, muzzle, crack, muzzle, crack, muzzle. So in this case, because the lag between the two, or the time of arrival between the supersonic crack and the corresponding muzzle is only 42 milliseconds, then there's essentially, no lag between them, and there's just one-for-one mapping. If we go to the tail end, let's go to the tail end of volley 9. Volley 9 is one of my favorites. And here we see, outside of the kind of the echoes at the end, we see a lag that is about, in this case you see the lag is 13 for this last one, 15, so that's very, very small. And as you can see, it's at the very end, you have a supersonic crack followed almost immediately by a muzzle blast. What do we hear? Well, let's select about 10 of them and listen. But before we do that, it's important to notice that most of the power, this top graph is kind of a power graph, most of the power, as indicated by the brightness of the signal here, is contained within the muzzle blasts, and very little of it is in the supersonic crack, and when it is, it's kind of smeared, as I call it, and the ears won't really detect the difference between these two because they're only 20 milliseconds apart, so it's going to, in my estimation, sound like one shot for each round. So let's highlight it, select it, and then play it a couple times. Four or five shots, right? Yes. One, two, three, four, five. So both the crack and the muzzle were heard at the same time, approximately, and the ear interpreted them as one sound. So in this case, we have at Oasis Apartment, you can see that both the crack and the muzzle are clearly recorded and distinguishable. But what we hear is just one round. So again, these aren't fake sounds because you can't hear that trailing sequence of muzzles. You can't hear it because the lag is small, and the ear can't make out the difference. So let's go back and listen to a recording where it's big. And we can go back over here and pull up our graph and see that right through there, just past the sound booth and out there, well, I know that there's a recording out there made by the guy who's standing up and saying it's electrical. So let's go find the electrical guy. Alright, there we go, Alt Electrical. And again, Sonic Visualizer. What were we looking at? Volley 9? I don't remember which volley is this. But, oh yeah, we can go over here to volley 5, I guess. Okay, so here we're looking at volley 5, burst 3. And once again, you see that we have 16 sounds because there's 8 rounds being fired, and so we got 1, 2, 3, 4, 5, 6, 7, 8 muzzles. And this is very much like, you know, the stage front one that we showed in the paper that I first presented, and we have 8 cracks up there. So since we're anticipating at least 4 or 5, a lag of 0.4, 0.5, then we do in fact have 1, 2, 3, 4, 5 muzzles following that last supersonic. And so the map sort of agrees with this, and if we measured it, which is certainly more accurate than the map, we get about 0.45 as the lag. Alright, what does this sound like? Well, let's just highlight it all. Come on here, guys, okay. Let me turn off the noises made by the... There we go. Loop it, and then play it. So you see we get the ticks up front from the supersonic crack alone, then we get the muzzle mixed in with the ticks, and then we get the muzzles trailing. Which if we slowed it down, it becomes much more apparent. Yeah, I call it the washing machine sounds for the muzzle blast. But again, you'll hear, 3 or 4 ticks followed by tick mixed with muzzle followed by 5 muzzle. All right, so and this is an example where we hear that trailing sound. Okay, but in the previous example we didn't hear that trailing sound because the lag was small. In this case the lag is big, therefore there's time for enough bullets to, well, not bullets, but the lag offsets the sonic crack from the muzzle, and because the lag is big, there's a bigger number of muzzles at the end. When the lag is small, there's a smaller number at the end, and the smaller the lag gets, the less able we're to hear and distinguish them. And when there's only one, it just sounds like one sound. So it's not true that if you can't hear this trailing muzzle, it's a fake sound. It's not a fake sound. This is a real sound. In fact, when the primary example of this not being fake sound is that this lag for the same exact round fired produces a lag that varies like this. So we fired one round. If we fired one round and we recorded it at Oasis, we would record, a small lag, and it would sound like the supersonic crack and the muzzle would be very close together, and it would sound like one sound. But out here in the red zone, what we would hear is the supersonic crack first, and then half a second later we would hear the muzzle. And that's the distinguishing thing. When the lag is loud, you can more precisely hear the muzzle separated from the supersonic crack. But as that lag decreases, because you're further and further away from the path of the bullet, or you're closer and closer to the source, either one, then there's not as much distinction. Alright, let's take a couple more. Let's go to Raymond Page, who's in the yellow zone. I know him to be up there. And we would predict that he has a recorded lag of about 0.3, and therefore there should be 3 muzzle blasts trailing the last sonic crack. And this kind of looks like volley 9, yes, because volley 9 is the only one that has 3 sub-volleys, with the middle one being big. Alright, so if we go look at the tail end of volley 9, and we can once again, we predict that we have 3 muzzles trailing the last supersonic crack, then that's precisely what we get. There's 1, 2, 3 muzzles, then a crack. Muzzle, crack, muzzle, crack. And if we listen to that, then you hear that 3 at the end. Or if we just listen to them separately. Okay. So, in the case where the lag is large, you're going to be able to hear those trailing muzzles. In the case where the lag is small, you're not going to be able to hear them, because they're going to be too short to hear. That is, too close to the sonic wave, or for other reasons. You have to also consider that in this case, what we have looking at the energy is that the energy for the cracks are spread over a broad spectrum of frequencies, whereas the energy for the individual muzzles are all conglomerated down here below 1 kilohertz. And in this case, it's hard to tell exactly, but I always use this one as a gauge of what's being heard. So in this case, I would expect that the muzzles were substantially louder than the supersonic cracks. In the case of Oasis, over here we see that it's the same thing, that the muzzle is much louder than the crack. In fact, compared to the crack is almost non-existent. But this is not always the case. If we were to look, let's take another one. Let's find on our map, if we go over here and look at the cop cams along the boulevard that go from point 2 to point 3 and pick one, let's see. No, that's not lag that you're hearing, that's a train. Let's see. There we go. This is one of the first ones that was released. That was, you know, that collage of pieces of videos from various cams put together. And what we want is within the first 58 seconds. Getting a little slow here. Okay, there we go. Coming up on volley 5. Let's see which one is easiest to look at. Nah, probably that one. So once again, this is volley 5, and we're going to look at the third burst. Now we expected, what, 0.3 roughly speaking? Okay, in this case we've got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we got 4 muzzles trailing the last crack. And in this case, you'll notice that the crack energy is big compared to the muzzles. Okay? So it's not always the case that the muzzle is larger. In this case, you know, we're fairly close to the bullet trajectory. Therefore, the supersonic crack is loud. And in fact, it's so loud that it extends down into the frequency range of the muzzles. But the muzzles are still distinguishable because they don't go all the way down. They're just kind of hanging in there between them. So let's listen to this. I guess we'll just listen to the whole thing. I don't know why this one's so slow. I must have a bunch of other graphs on there. Come on, baby, you can do it. Alright, there we go. Loop it. Play it. So slow it doesn't even want to give me a nice little... Oh my god. So you see, in this case, the muzzle can barely be heard, and we hear the sound of the bullets, and they're also sound like they're hitting something. Let's get rid of that one because it's really slowing things down. Alright. So, once again, I'll summarize this. Because you don't hear the trailing muzzle blast, that's not an indication of a fake sound. It's quite normal if you have small lag. If you have large lag, then you will most definitely hear the muzzle if there's enough volume or signal to noise ratio to hear them. It's not always the case that the muzzle is going to be louder. It could be the the shock wave if you're close to the path, which in fact to have a fairly large lag, you're going to have to be close to the where the bullet was traveling. Let's add one little more thing to this. Do a little drawing over here. On this plot, if we travel from the lower left corner to the upper right, lag increases. Alright, so the closer you are to the source of the sound, the smaller the lag, as indicated by the bluish things here. Also, if you travel, and let's let this big line represent the path of the bullets. The further away from the path of the bullet you get, you can see that the lag decreases also. So maximal lag occurs along the path of the bullet. The minimal lag occurs either close to the source, which is probably right in here somewhere, or at distances far removed from the path of the trajectory of the bullet. Alright, but in all cases that I've looked at, if the signal is good, you can record both the muzzle blast and the supersonic crack. Alright, so that about wraps it up, and we'll grab you in the next one.